Here's a fun little exercise that is inspired by a coding mistake that I have seen relatively frequently in students and also myself. I may have made this coding mistake once or twice. Okay, so this concerns indexing uh, matrix V, where V is the eigenvectors matrix. Now, you know that the eigenvectors are in the columns of this matrix. They're not in the rows, they are the columns of this matrix. So what I want you to do in this exercise, exercise 2, is to recreate figure 13.1, and I'll go to this figure in a moment. But instead of using the columns, you want to index the rows. Now this is wrong. This is incorrect. It's debatable whether there's a coding error because Python is not actually going to give you a warning message or an error. It's really more of a math error than a coding error. But these incorrect results will be insightful because it's going to help solidify the geometric interpretation of eigenvectors in your mind. Okay, so let me show you figure 13.1. Here is figure 13.1. Now all the code to produce figure 13.1 is already in the on my GitHub site. So to solve this exercise, you don't need to recreate all of this code. You can just copy and paste the code to produce this figure, but you want to change what's happening here on the left panel. Now, when you look at this left panel, you can see this perfectly illustrates the geometric interpretation of eigenvectors. So we see that there is some vector, let's say v2, and this is the vector, and then we multiply the vector by a matrix, and the matrix does not change the orientation of this vector. It only made it a little bit longer. So it scaled the vector without rotating it. And here in black, so here's the original vector, and then when we multiply that vector by the matrix, we see that it's on the same subspace. So the subspace stays exactly the same, and the eigenvalue is going to be minus, I don't know, whatever this is, minus 0.7, something like that. Okay, so this is the geometric interpretation of eigendecomposition, and now the idea is to recreate this figure, but indexing the rows instead of the columns. So this code here is almost exactly copy-pasted from earlier in this chapter, where I create that figure. So here's the matrix. Here I take its eigendecomposition, and here's where I define two random vectors that are not eigenvectors. These are just random numbers. Okay, and then here I multiply the matrix by these two sets of vectors. And here I'm doing the plotting, and actually let me first show you this plot, and then I will talk about it. Okay, so don't worry about the right side of this plot. We can just focus on the left side. And what you see very clearly is that this vector here is rotated after being multiplied by the matrix. Now this means, and also the black one, this means that these two vectors are not eigenvectors of this matrix. Now that may seem strange because the plotting code actually comes from this vector's eigenvectors. And so this variable is the output of numpy.linalg.eig. So, either Python is incapable of computing eigenvectors for even a very simple 2x2 matrix, seems unlikely to me, or we did something wrong in the plotting, which seems much more likely to me. Okay, and here is the issue. The issue is with the indexing. So here I'm plotting eigenvectors, so row 0, column 0, and row 0, column 1, which means that it's the same row, but the two different columns, and that is wrong. If you scroll up and look at the code from earlier in this notebook file for creating figure 1, you will see that it actually should be indexed this way, like this. Oh wait, sorry, should still be 0. Yep, like this. So the matrix is correct. I'm just indexing it in the wrong way. Okay, so this was actually still wrong. And then I had to take a moment, pause the recording, and see that I had also swapped the indexing of MV. So I was plotting eigenvectors wrong, and I was also plotting MV wrong. So there I was also indexing the rows and not the columns. But that is even more insightful because, yeah, I mean, you see it with the geometry. I think the important lesson here is you always have to be very careful of how you are indexing matrices, in particular with these eigenvectors or any matrix where you are expecting something to be in the columns. It's easy to make these kinds of indexing and dimensionality mistakes. I have done it once or maybe more than once in my life, and so I hope that you will learn from my mistakes and not make this mistake yourself.